I'm Amy Bryson, contributing lead editor of Smart Manufacturing magazine. Today, we will explore closing the loop, empowering your production from start to finish with 3D scanning. This presentation is sponsored by Octane. And in this webinar, you'll hear from experts from both Octane and Hexagon Manufacturing Intelligence. They will talk about how introducing 3D scanning technology into your production process can yield optimal parts with fewer design iterations. You'll also get some practical guidance, tangible examples, and learn how the right reverse engineering tool set can bridge the gap between data collection and CAD design. Our presenters today are Greg George and Brian Winters. Greg is an applications engineering manager at Octane. Now, he's been in the 3D scanning and engineering market for more than 17 years. And in his current role, he's responsible for supporting the Octane Geomagic software suite. And Brian is the North American product manager for Absolute Arms at Hexagon Manufacturing Intelligence. Brian's focused on new product development and targeted markets while working closely with the product technical staff. Before I turn things over to our presenters, I'd like to go over just a few housekeeping items for our attendees. Now, on the right-hand side of your screen, you'll find a question and answer box. If at any time during this presentation you'd like to ask our presenters a question, just type it into that question and answer box and it will be answered at the end of the presentation. If we run out of time, the questions will be sent to our presenters and they will respond via email after the presentation. If you're not able to regain access to the live webinar, if you have any technical issues, don't worry, this presentation will be available in recorded form after about 4 o'clock Eastern today. And if you do run into a technical issue, just type that into the Q&A box to alert us and we'll respond individually with a fix. And after the webinar today, and when it's in its recorded form, you can watch it as many times as you like. All you need to do is sign in with the credentials you used to join us today. And feel free to share those credentials with any colleagues who you think might also benefit from our topic. Now it's my pleasure to turn things over to our presenters. Welcome, Greg and Brian, and thank you so much for being with us today.
Thank you very much, Amy. So let's go ahead and go over our agenda. So today we're going to talk about a little bit about who we are, and the companies that Brian and I both represent, and why you should care about 3D scanning and all the benefits that go along with it, and the powerful reverse engineering and software inspection tools, as well as the methods of data collection, as Brian will speak to here a little bit later. We'll talk about a very specific part that we have here that we're using as a use case, a test case to show the benefits of the process that we're going to talk about. And then we'll talk about how we were able to use that as part of a process along with 3D printing, and how we were able to optimize that. So let's go ahead and jump in and talk a little bit about who Brian and I represent, our two different companies. So I'll go ahead and go first. I am from Octane, and we are a company that specializes in intelligent manufacturing, and we have a comprehensive software solution suite that specializes in a lot of different additive and 3D scanning applications. We have software that enables you to complete MOS things, from MOS with traceability and visibility for a full organization, along with AI powered tools that are paired with that, as well as the specific products I'm going to talk about today that deal with 3D scanning and 3D printing. So we're an industry leader. I'm going to be talking primarily about some Geomagic Suite softwares today, but we're at octane.com, or you can find us on LinkedIn. So we'll go ahead and have Brian introduce the company he represents.
Thanks, Greg. Thanks, Amy. Glad to be here today. Yeah, so Hexagon is a global company with many divisions, geospatial, mining. Our division is manufacturing intelligence, and we do a large focus primarily on scanning and inspections for quality. So as we've evolved some of the sensors that you're going to see later today in the presentation, we've started moving into more of the reverse engineering aspect, and the accuracy of these sensors is unparalleled in the market, right? So we continue to work with our partners and our customers to continue to push the envelope and figure out new places where we can use this technology at a level that it has not been seen before. So more information at hexagon.com, and later on in the presentation, I'll be talking about some of the other local events where you really can go see a larger offering for all of the Hexagon different divisions coming up at Hex Live.
Perfect. So we'll go ahead and start with the 3D scanning portion of our workflow, and I'll have a few slides that kind of show an overview of the entire application. But the first thing we wanted to do is introduce the products that we're working with this application. So obviously we're doing some 3D scanning, and right here we're going to talk about Geomagic Design X and Geomagic Control X. I always like to use this slide because it kind of shows an overview of how the process works with our software communicating with the sensors that Brian is talking about, and then showing how we can take that information and hand it off to a lot of different applications downstream. And I feel like this slide is pretty powerful at describing the different areas and places you can go with that information. So really what the Design X software is specializing in here is taking that scan data straight from the sensors and handing that off to other software applications, whether it's CAD, CNC, or additive, as we're talking specifically about today in this presentation. Now, I tend to like to talk a little bit about some of the details and do a little bit of education on different types of deliverables and file types here. So what DX in this instance is really specializing in doing is taking that scan data and converting it over to CAD information, allowing you to use that CAD file that is editable that we can then do things downstream. So we can scan directly to polygons or directly to point clouds with the arm and bring that inside of DX and convert that over to CAD, which we'll talk more specifically about here in a few minutes. Now, some of the deliverables that you can get out of Design X are a mesh, quick surfaces, feature-based CAD models, or in this last instance here is the ability to take and use quick surfaces and feature-based together inside of one deliverable. So I like to just simplify it down. There are other deliverables out there that you can extract from it, but these are kind of the top 4 things that people will do using the software and exporting that out into other formats. So we will start off with kind of like a traditional 3D scanning and reverse engineering, and then we will also highlight another software in our portfolio here, Geomagic Control X. So what we're going to do with Geomagic Control X is a couple different workflows, as you'll see as we get into it. We're going to take the CAD design that we created from reverse engineering. We're going to manufacture that, in this instance with additive. We're going to then measure that with the Hexagon arm, and then we'll do an inspection. So that's kind of a traditional workflow that we see in the market all the time, and we're going to use that for this, but we're also going to take and add another level to it. We're going to take and create a topology optimized part, print that, scan the topology optimized part, inspect it, and compensate it. So we'll go over more about that here in a few minutes. But before we do, we'll just go ahead and hand it off to Brian to talk about what device and how we're going to collect that information.
Perfect. Thanks, Greg. So yeah, Hexagon has many products that we offer. The one that we've used for this workflow is the Absolute Arm, which is near and dear to my heart here in North America. And then the ARM, I think in its legacy name, is maybe still a little bit more well known. It was the Romer ARM at one point, and then Hexagon came along and purchased that company years ago. We're very proud of the legacy, right? It was founded in Southern California. The factory's still out there today. So we're very, very proud of that. And it's kind of risen up through the aviation boom and all of that that's happened out in California, right? So what is the arm, right? So basically it's a piece of equipment that's designed to move out to the part so that you wouldn't have to bring the part to a stationary measuring machine. So it's also called a portable coordinate measuring machine. That's how it started, and since then it has evolved. We're on the 8th generation now. So what does the product offering look like today? So today we have, basically it comes down to 6-axis or 7-axis. The compact arm is a 1.2 meter. It's probably our most accurate probing arm. And it's also a 6-axis, so that's why I say it's 6 and 7-axis. The 7-axis, you can also do probing, but you can also upgrade it into scanning, which we'll see on the next slide. But for these purposes, think like BMW, 3 Series, 5 Series, 7 Series, right? Like good, better, best. Although someone's pointed out that I have to stop using that analogy because now there's like 12 series of beamers running around. So maybe we'll have to work on that for the next one. It also comes in a variety of sizes, right? So the smallest is 1.2 meters and the largest is 4.5 meters. Okay, here we go. So talking about the modularity of the arm, one of the best things that's happened since this has come out is that the wrist functionality, which you can see there in that image, it all comes apart. So it's like different building blocks. You've got different pistol grips you can put on there. You've got different probing tips. You've got area scanners. You've got entry-level scanners. The scanner that we're going to be talking about today is the AS1, and it really has become our flagship. And in fact, we're going to move to the next video here, and I'll show you why. So here you can see kind of a different paint swatches, if you will, different car finishes. What it's really showing off is the SHINE algorithm. And what that stands for is Systemic High Intelligence Noise Elimination. It is the standard on the AS1. There are some additional settings that you can use to dial in some more intricate parts. But what we found is that in the past, you had to have different scanners and different presets for different types of parts. That's no longer needed with the AS1. So we're now able to go through and just put it on there and pick up any type of finish. And why that's important in this flow, as Greg will kind of point out, is there will be different materials or different substrates as you're going through the process. And this one scanner captures all of them, right? And so lastly, here on this slide, you can see Hexagon has a lot of toys. The arm is kind of the entry-level point, and really it's kind of, you can get in the game for not too much money, or if it's something that's not of interest, we have contracting locations all over the country, like over 50 in the US alone. So if you just need help creating a digital twin to get into this additive workflow, or you just need some inspection, we can support that request as well. It's not always about sales, it's about supporting our partners and the customers and the market needs as we go along. And here in this video, you'll see some of the other applications that the data. So a quick story before I hand it back off to Greg. That scanner originally came out as an RS6, which is Romer Scanner 6th generation, and it did so good. And I think you saw it in that last video that we crossed it over into the Leica tracker line. So there's a little adapter that lets you use that same scanner, take it off the arm, stick it onto a tracker, and now you're able to scan the side of an airplane or whatever else you want to do for inspection, or if you want to make it a micro model, right? So it's very, very powerful, and it's also evolved into the HPL 1010, which moves so fast it could probably knock you over if you're not careful. But we were able to successfully use that to scan both of these parts here in the Detroit office. And now I'll turn it back over to Greg so we can talk through some of those workflows.
Absolutely. Yeah. Thanks for that introduction. So as you can see, you use different devices for different reasons to collect different sizes, different accuracies. Um, and you take that scan data, and what we're going to talk about is a very specific application with this part here. We'll move to the next slide, where we have this recumbent bike here, where there is a piece that's underneath of the seat. And we went ahead with this application and we scanned this part and we reverse engineered this part. And what we're going to do is just show all the different things that you can do once you've captured and reverse engineered this piece. So we'll just go over the process to start from the very beginning. We have this piece and we're going to bring that inside of Design X. So you'll see here as this video loads, we're going to jump into the scanning and data collection part of it first. So the process is we're going to collect the information, and Brian can elaborate a little bit more on what he did because he actually scanned the part.
Yeah, so the funny thing is the scanner moves so fast, it actually took me longer to get here and get back from with traffic than it did to do the process, right? So what we're showing here on the screen is basically you take the part, you elevate it, you scan one side of it, then you flip it over, scan the other one, and you mesh the data together, and now you've got a digital twin, right? That's it, that lives in the point cloud. And that data, we take and clean it up, and then you feed it back into Design X. And then from there, you're able to go through and start some of your optimization and analysis as you're going through. But here you can just see some different B-roll footage that we put together late last week to show how easy it is to scan. It really is just like, using a paint sprayer, really, except you don't need paint or stickers for this arm, which is even nicer.
Absolutely. Yeah, so Brian was able to scan that in, and he was in a completely different location, right? I'm down in North Carolina. He actually takes that part and scans it, and he digitally sent that to me, and I loaded that up inside of Design X. And that's actually what I was attempting to start to show before and talk about. This is the process that I went through. I went ahead and showed the entire modeling process here in Fast Forward. So what I'm doing here is I loaded up that scan, and one of the most important tools here that DesignX has is that ability to interact with the mesh as a CAD tool. So we are essentially a CAD software that has scan and mesh tools built right into it as native entities. So what I'm doing is I'm modeling directly over top of that scan data, using it as a reference. To be able to extract the dimensions, extract the features, and model directly over top of that scan data. So you can see as we go along through the process, we're just reverse engineering each different section where I go ahead and I'm going to cut off the top where it mounts to the top surface tube here. And we're creating fillets that are automatically calculated. Those actually you can see are automatically calculated using the underlying mesh. And then I use a 3D comparison tool to show how closely we're matching that. Now you can see that we're just extracting over and over again different features, and then intermittently I'm going over to the accuracy analyzer and comparing the results of the things that I'm modeling with the original scan data to make sure that I am modeling something that is accurate to what's there, right? So I'm modeling directly over top of that scan data and then constantly comparing back and extracting that CAD information from it. Here, I'm using what we call a lofted wizard. So our loft wizard, I can just select a region of the mesh and tell it create a surface loft and use that surface loft to automatically cut the solid model there. And again, final details, we're adding some fillets. And again, you see that we're doing 3D comparisons and adding all the hole locations. So what we're doing is just capturing all this to create CAD geometry that I can use and modify and work with inside of a CAD software. So in this instance, what I'm doing now is I'm using the live transfer tool inside of Design X to take everything that I've modeled so far and send it over to SolidWorks. And you see here, what it did is it built all of those native features as SolidWorks editable features inside of the SolidWorks platform. And what that allows you to do is once it's in the SolidWorks platform, you have that entire tool set. Anyone that has that software inside of your organization can work with it, can edit it, and even bring it into assemblies, drawings, analysis tools, and work with it from there. So after we reverse engineered, so we went ahead and we chose this part for this application, and we went ahead and reverse engineered it. Now we wanted to take it in and run some topology optimization on top of this part and create new geometry from it. So the reverse engineering process was helpful here because we were able to quickly extract all of those features and bring them over into another software that we have over here at Octane called 3D Expert. So this is just an overview of the process, which I'll speak to here in a second. As another video plays, we'll show you what we were able to do is load up that geometry that I created inside of Design X. And we're going to load up that geometry and identify the different categories of information here that we have on the left-hand side. Create an analysis volume, a preserved volume, the fixed boundary conditions, the forces, and different functional surfaces. And once you identify those, you can then apply forces and then run calculations and create a piece of geometry here that we can use as a topology optimized part, right? So we can lighten it up significantly using that whole process. Now from there, as you can see, that is a highly organic part. So we went ahead and brought that over to the additive workflow where we went ahead and we printed it and used this test case using 3D Systems 2500 jetting technology. So the ProJet MJP 2500 Plus, right? And we brought that over to that printer and we were able to print that geometry out, right? That would otherwise be pretty difficult to manufacture, right? Because this is highly organic shape. And this is where we wanted to talk about how the inspection software and measurement tools tie in, because in this instance, what you have is a very organic shape that we want to inspect. And that's where laser technology or even the white light technology are very useful to capture these highly organic shapes and inspect them. So that's what we did. We went ahead and printed this part out and we went ahead and scanned it for a traditional inspection. And this is what the workflow typically looks like, right? Where we print, manufacture, measure, and then inspect. But what we're going to do now is go ahead and bring that, and I'll kind of give you an overview of how we were able to take that scanned part and align it and use our Geomagic Control X to inspect the two pieces. So in this instance, I'm actually doing an inspection with the original mesh that was the output of our 3D Expert software. And I brought that in and I made that as the reference. And then I am now bringing in the scanned output print. And then we're going to do an inspection. We're going to validate whether or not this part is ready to go be used, right? So in this process here, what I'm doing, because it is a mesh to mesh or scan to scan type inspection, I'm creating some features ahead of time to use to create different dimensions and to create for alignments here. So I'm going ahead and creating those ahead of time. Now, if I used a CAD model as my reference, I wouldn't actually have to create any of those reference entities. We use the CAD faces from there. So now I'm using those datum entities to create an alignment, a datum alignment. And then now we can jump over and create a 3D comparison. So now you can see the variation between the printed part and the original mesh that we input, right? And this is just to show that the different things that happen during the manufacturing process. This is just highlighting how you can validate, is this part meeting the specifications in order to ship and use this. So in this instance, what we're doing here is with the 3D comparison, we're pulling out some different comparison points, and we get just validation of these different locations on the part, how close that scanned part matches the original that we printed here. So that's just one type of tool that we can use. Another type of tool from here is we can come over and we can create dimensions. So I'm going to go ahead and take all those features, and you can just pull out and say, I want to create an angular dimension from that top axis to, to the bottom of the part. And you see here, I'm going to measure the height of the part. And you can see that we're going to go ahead and measure those different radii and extract all these just dimensions. And remember, this is a scan to scan dimension. So in this instance, I'm comparing the STL before or the mesh before to the after, but you could always take a scan of your own parts from yesterday and today and compare them together as well. There's all kinds of variations. Now from here, I go ahead and create a report, and you can output this for the validation of that part. You can say whether this pass or fails. Is this good enough to go ahead and use or not? So that is an overview of the traditional inspection that we did. I say traditional, I mean, many years ago, that wouldn't even be considered traditional, right? Taking a laser scanned mesh with millions and millions of points and comparing it back to either CAD or another mesh. But I'm saying that compared to what we're going to do now. So the next step here is, this is an overview of what we're adding to this workflow here. So to kind of recap, we have the CAD design that I created using DesignX. We created a topology optimized design. We went ahead and printed it. We scanned the printed part, and then we measured it. Now, let's say that we want to print another one that's closer to the ideal. So we can go ahead and actually run this compensation process using our 3D Expert software that we mentioned before that created the topology optimized part. So I'll just go ahead and hit next, and we have a video quickly showing how that process works. So we're able to take that output scan, and we're going to load in the original information that the topology optimized scan data, and then the original scan that we printed out. And we're going to align those two together in here inside of Expert. And what we can do is go ahead and compare them to each other. So we're going to assign different colors here so you can see the deviation between the two different parts. Now, in this instance, what we can do is we can compensate the piece by taking that deviation map of the two different pieces, and we can offset and deform the shape of the original input geometry to the additive manufacturing device. And you'll see that it's going to run that compensation, and it's got a preview of all the different measurement locations around the part. And then it's going to create a compensated model that now we can use for our printing process here. And we'll go ahead and kind of zoom in here. We'll rotate this part around. You'll see it in the video where you can see that we have the original, we have the 3D scanned, and then now a compensated piece of geometry. So that way, when we go ahead and create a print off of that, it'll be significantly closer to the ideal geometry that we expect when we output it on the 3D printing device, right? So that's what we're showing here. You can kind of see 3 different scans and the overlay of the 3. So now you can go back and you can 3D print in a compensated version of that part. So just to wrap up, we can go ahead and kind of talk about some final thoughts here and give you a little bit of information where you can get more information about our products. And then we also have some time to take some questions. So
Perfect.
For the wrap-up section, Brian, do you want to comment on the data collection process?
Yeah, so like Greg was talking about in the previous slide, there's an iteration that happens there after you get all the way down into offsetting and optimization. And this is where the arm really thrives, right? Because it becomes basically a Swiss Army knife of different probes and options that you can use to really dial it in and just get down to the finest resolution. So yeah, that's an exciting one that we're starting to see, like I said, all over the place, and we're happy to continue working with Octin and 3D Systems as we go along. And this is kind of all new to the market right now that it's additive's not new, but it's finally becoming more mainstream. So we're starting to see a lot more people want to enter this. And I think that's why it's important that we have some of these educational webinars about the tools and the processes that are already out there for everybody to use. Yeah, so wrapping up, like I said before, there are many Hexagon locations across the United States. If anybody's interested in coming to see all of the different Hexagon divisions under one roof, it happens once a year in Vegas. At Hex Live is the event, and that QR code there on the screen will send you to a landing page. And then, I think in the other coming slides, there'll be a subsequent QR code for the arms coming up, but I'll let Greg talk a little bit more about the data processing.
Absolutely. So yeah, the products that we used, as I mentioned throughout the presentation, were Geomagic Design X, Geomagic Control X, and our print software 3D Expert, which is amazing CAD-based 3D printing tool in the market that also has all kinds of different functionality that we talked about during this meeting. And yeah, we do have some time for questions, but here is the QR codes for the different products that we mentioned inside of the webinar. So hopefully we showed how, with a little bit of creativity, you can take these different products and use them in conjunction with each other to create digital twins, and string together this like a digital thread of the different pieces of software together to create different applications. And really what we wanted to highlight is just a really interesting one that we've seen in the market lately. So yeah, let's go ahead and transition over to taking some questions.
Sounds good. Thanks again, Greg and Brian, for sharing those examples. I think that's always really helpful for our attendees to see kind of the paint on the canvas, as they say. So let's jump on into some questions. So first and foremost, someone wants to know, how long did the reverse engineering take? And that's a question I think a lot of people have is, how long does the process take? Someone else said, how long did it take to create the model from the scan that you showed during the presentation? So maybe you can address that kind of macro question.
Yeah, absolutely. So as you can, I'll summarize both sides. Like Brian said, for him, it took longer to drive to the office than it did to scan that part. So the scanning part, what was it, like 10, 15 minutes maybe?
I think you can call it 10 if you let the computer boot up and do its whole thing, right? But the actual act of doing the stripes and the scanning is very, very quick.
Yeah, and then for that part, really, it was like less than 30 minutes of modeling time, honestly. So I fast forwarded that video. I actually showed the entire process in that video, and I condensed it. I forget what speed it was. It was like 5x, and just cropping it down so it would fit within a reasonable amount of time to describe it. But yeah, 30 minutes. Now, I recognize that I'm a skilled operator of the software. I use it every day. But people that have CAD experience and understand how to model parts usually settle right in with a software like Design X, and they kind of understand how to use an extrude as an extrude, and loft, revolve. Those types of things are very similar in the different software packages.
Great. That's very helpful. Someone wants to know, is there any way to automate the inspection process?
Absolutely. So this webinar highlighted how I can bring in a one-off part and create measurements between two different mesh models and inspect them. But Control X primarily specializes in more automated inspection. So in what I call, again, traditional scenario where I have a CAD model that we've manufactured, I can load in a piece of scan data and it's fully automated. It'll make all those dimensions and output those. And I always say that there's 3 different kinds of automation. You can do one-off ones where I just load up a part and then hit regenerate and it'll spit out a report. We can do batch processing as well, where we just select a folder full of parts and tell it to measure all of those. And then the final one is we have this full automation server option for Control X, where it'll just, as a scan comes to it, it'll grab it and then inspect it and output the results as well.
Great. Wonderful. Another question we have, are there size limitations to the size of the part or number of data points creating the mesh?
All right. So we can address, yeah, there's kind of two categories there. As far as the limitations, yes, computers do have limits of the amount of data that they can handle. And the devices that Brian's devices, the data that their devices produce, you can produce millions, even billions of data point measurements, right? But I always like to give people just general ideas of what is big, medium, or small, like, you know what I mean? Just as a general idea. So for my general demonstration models, I use like 1 to 2 million point or polygon count files as my demonstrations. Now, something like a SolidWorks would struggle to even load that or work with that, right? So those are considered small to us. And then in a medium range, as you're talking about, I don't know, 2 to 10 million is like a medium-ish range. It all depends on your computer hardware, right? And then I've loaded up 50 million points before, right? Like, so it all depends on, you know, how robust your computer is and how much time you have, because it does take a decent machine in order to run that. So that's as far as the sizing of the data. Now, as far as Brian, what are kind of the envelopes of the different devices that you guys offer to give people an idea?
Yeah, so on that one slide where we had all of the different Hexagon hardware offerings and solutions, kind of at one end of the spectrum, you have the UHA machine, or ultra high accuracy. Now, these are, you know, sub-micron level accuracy. And really, we see a lot of the customers that have these for applications or parts where they need a 0% chance of failure, right? So very, very high end. And then at the other end, you can talk about our Leica long-range trackers, right? Like, they've actually used these to scan Mount Rushmore and miniaturize that into a 3D print, or, you know, scan the outside of a 747, or even, you know, use it to set up a coordinate system on an aircraft carrier. So we're in all kinds of very, very interesting applications, right? And we have a tool for whatever that job requires.
So there really isn't a limit on the size of the parts you can scan.
No.
Wow. Great. Another question, are you compensating the CAD model to better match the as-built data, or are you compensating the 3D printer build file to make the printer output closer to the CAD model? Sounds like a chicken or the egg to me.
Yeah, so it was the second option. I'm compensating the output of the printer to then input it back into the print to get closer to what you're basically squeezing every micron out of it, right, to be able to compensate. Now, we also, in that software, I'm highlighting a specific piece of functionality with this workflow, but we do have build simulation inside of our 3D Expert. So that is another piece of functionality that can more accurately predict the types of deformation that happens depending on the print technology that you're using, right? So we can help predict that ahead of time. But what I'm really highlighting today is that even scanning the output and inputting that back in to get closer. So in this instance, it's somebody that's trying to, again, squeeze every micron of accuracy out of what the technology is capable of doing.
Okay, great. Another question. One sec. Let's see. What is the width of the laser stripe on the scanner?
So on the AS1 scanner that you saw, you see a red stripe and you see a blue box around it. The width of the stripe at the optimum length is 150 millimeters. And then it has a kind of a range finder, which you may have seen in some of that video footage, right? So as it rolls over the part, it'll say you're too close or too far. But as long as you're within the blue box, you're still taking data. This is very helpful whenever you're going over big sweeping contours. And you can use it in conjunction with touch probes, right? So if you're trying to get a blind hole and you want to see where it is specifically in the model, you take that and then you can combine it into the scan data, right? So that complete model would then be what goes into Design X or Control X for evaluation at that point.
Sounds like that's important when you're talking about those really organic shapes.
Yes.
Absolutely. Great. Another question then you had one slide that talked about options for hardware to use for reverse engineering and inspection. Can you talk about some of the different examples?
Yeah, so the different examples that we have, again, it's comparable to the U-Haul and the tracker, right? Like there's a wide variety. But even for the arm itself, which is often the entry point for a lot of metrology customers, they're very amazed when they say, well, you can use almost 100 different probes. You can make your own probe. And then we also have an SDK program for people that want to develop something that doesn't exist yet. And we're seeing some very, very interesting creations. Something for surface roughness will be coming out soon. They're going to talk a little bit about it at Hex Live if you want to show up and see what it is firsthand. And then we've got some other ones, right, where they've gone and they've coupled into an NDT. So they've figured out how to shoot ultrasonics through a part. And so they're kind of scanning inside the part or inner scanning or whatever that term becomes. And it's all great because it all lives on the arm, and that's made possible by our TKJ, right, our Tessa kinematic joint. So once that probe, whether you design it as a custom offset or something else that you end up developing with an additional scanner in the future, once it's calibrated to the arm, you can take that part off as the workflow needs, set it to the side, go back to scanning, say, oh, there's another hole. Let me switch, hot swap it back off, put it back on the arm, and start your probing function. So all of that data is not, it all just continues to combine as you go along into the different workflows.
Great. And here's a question you probably knew was coming. How much does the arm cost?
Yeah, we get that one a lot. Right now, we have a promo running, I think, for the rest of the year, and it's the compact arm with a full seat of software in the low 20s, which is pretty much unheard of. And of course, it'll always vary depending on what type of solution or options you want to put on it, right? So if you want a 4.5 meter arm with a grid lock and a tool lock, I mean, you could be up into the 120s. So there really is something kind of for everybody's application in between.
Great. The questions keep coming in. This is great. So is there a scanner like the AS1 with a bigger area of scan?
Yeah, so the AS1, and you may have seen it in that one video where you have the robots running around with the trackers. The AS1 actually comes off of the arm, and you can put it onto a tracker, and that lets you kind of do station moves all the way around. So you can use the AS1 to go ahead and capture a much larger area, right? And you can do the same thing with the arms. In fact, you can do station moves and then put it all together. It just kind of depends on the overall volumetric scope of what your project is and what that entails. If you'd like to learn more information, please send me a note, and I'm happy to talk more about it with you offline.
Wonderful. I'm just checking to see if anyone has any last-minute questions while we have our presenters all to ourselves. Looks like that might be it, gentlemen. So I want to make sure that I take the time to thank our presenters again, as well as to our attendees for your participation. And they're very open and obviously are there as a continuing resource if you want to continue the conversation after this webinar. And always remember that SME and SME Media are here to help you stay up to date on all things manufacturing. You can find links to our podcasts, webinars, publications, and breaking news by visiting sme.org. And we hope that you found today's webinar informative and that you'll join us again very soon. In the interim, take care, and we'll see you again.